Welcome to the video on the centroid. For this video, like the last one, you're going to need to use your compass and your straight edge because we're going to start by doing a little bit of constructions. So the directions say use your compass and straight edge in order to construct the median of each side of the triangle below. Do this carefully and with precision. Well, it's impossible to construct the median unless you know what the median is. So just a brief reminder, hopefully you already know what this is, but if you don't, reminder that the median connects any vertex to the midpoint of the opposite side. So in other words, we have to find a way, or we have to have a way in which we can construct the midpoint. We don't have a construction for a midpoint, so that's kind of a problem. One sneaky little way around this is that we know that a perpendicular bisector always passes through the midpoint. And we know how to construct a perpendicular bisector of a segment. So what we're going to do is we're going to construct a perpendicular bisector which will enable us to find the midpoint. And then once we know where that midpoint is, then we'll go ahead and connect that to the opposite vertex. So I'm going to grab my compass and straight edge, and I'm going to start by going ahead and constructing the perpendicular bisector of side AB. Like I did in the previous videos, I'm going to do each construction or each part of my construction in a different color to just differentiate between them. So for the perpendicular bisector of segment AB, I'm going to use blue. We've done this enough now so that we're hopefully starting to get very good at it. So I'll just grab my straight edge here and connect. And I think what I'll do is I'm going to connect this with a dotted line because I'm really not interested in the perpendicular bisector. Rather, what I'm really interested in here is the midpoint. So I know the midpoint is going to be the place at which the perpendicular bisector intersects the segment. I'm going to call this M1 because I'm going to go ahead now and I'm going to find the locations of two other midpoints. So there's my first midpoint. If I want to go ahead and finish this up, to construct the median, I need to connect that midpoint to the opposite vertex. So this guy here is my median. And again, what makes him the median is that he connects the vertex at C to the midpoint M1 of the opposite side. So there's one. I need to do all three. I'm going to go ahead now and find the midpoint of side AC by constructing its perpendicular bisector. And again, I'm going to make the perpendicular bisector with a dotted line because I'm really not interested in all too much the perpendicular bisector. What really interests me or intrigues me in this question is the location of the midpoint. This one I'm going to call M2. And again, to construct the median, I'm going to grab my straight edge and I'm going to connect that midpoint to the opposite vertex. So the solid line segments are my medians. The dotted or the dashed ones are my perpendicular bisectors. And lastly, I'm going to go repeat that same exact construction, but this time for line segment BC. I no longer need my compass, so I'll go ahead and put that away. And again, my perpendicular bisector I'm going to do with a dotted or a dashed line. The spot where that perpendicular bisector intersects the side of my triangle is my third midpoint. I'll then grab my straight edge and use my straight edge to connect midpoint 3 to vertex A. So just a reminder that my three medians are the three solid line segments. And what's really cool about these guys, like the three perpendicular bisectors, the three medians of the segment are concurrent. They all intersect in one spot. I'm going to get rid of that guy. He's an extra. He doesn't belong there. Notice that each one of the medians comes together at that point. They're concurrent. I'm going to call that point X. And just like we had a special name for the point of concurrency of the perpendicular bisectors, we also have a special name for the point of concurrency of the three medians. The name of the point of the concurrency for the three medians is called the centroid. So down at the bottom, I'm going to write the centroid is the point where the three medians of a triangle intersect. And like the circumcenter, the centroid has some special properties. And the special property that you need to know and be aware of and be able to use for the centroid is that the distance from the centroid to the vertex is exactly 2/3 the length of the entire median. So that's what this says in words. I'm going to go back up and explain to you what this means in your picture. And I think maybe in order to do that, I'm going to make one of these medians red and bold. So I'm going to take that median. The centroid then is that purple dot X. What this is saying is that the distance from X to vertex B is 2/3 of the entire median, which extends from midpoint 2 all the way to B. Or in other words, what this says, and I think this is an easier way to explain it, the centroid will split this segment into two pieces such that they're in the ratio of 2:1. So if you like remembering that the distance from the centroid to the vertex is 2/3 the length of the whole median, that's fine. I like to think about this in terms of the whole 2:1 ratio. And we'll explore this more in class when you come to class on the Inspire calculators. If you have your own Inspire, that's better still, because I'd be happy to download the file for you to your calculator. But for right now, what you need to know, again, is that whole 2:1 ratio idea that's associated with the centroid. All right, consider what was the purpose in watching this video this afternoon? Why did I want you to watch it? What did I want you to get out of it? Make sure that you take some time to reflect on that so that the next time you come back to class, you'll be prepared to utilize and apply these ideas about the centroid to further your own understanding.